Hello everyone and welcome back. So today let's start an example of using the instantaneous center of zero velocity to solve this problem. Can we do it? I believe we can. So let's jump right in. So first off, we have this linkage, its undergoing motion is shown, and the block is moving with a velocity of 3 meters per second to the right. We want to know the angular velocities of links AB and BD. So how are we going to do this? Well, we're going to find the instantaneous center of zero velocity and then solve for the angular velocities. Now, I'm not going to make you do this on your own. We're going to do this one together, and then as always, you're going to jump into it and try on your own with the next example. But let's jump into it. So first off, where do we know the velocity of the blocks? Like, which points do we know? Well, we know that this block right here is moving with a velocity of 3 meters per second to the right. And also, we know that this link AB, well, it's rotating around point A. Point A isn't moving, and so we can figure out the velocity of point B, which is going to be perpendicular to that, which in fact will be actually directly along this line right now. So, with that in mind, we know two velocities. We draw lines that are perpendicular to those two velocities, and we come to a point where they intersect, and that is going to be our instantaneous center of zero velocity. Now, luckily for us, we know an angle. We know this is perpendicular, so we know all of our angles. We know one of the side lengths, and that's enough to figure out all of the other side lengths. So we get that RD, the side pointing from the instantaneous center to point D, is going to be 0.566 meters, and the side pointing from the instantaneous center to point B is going to be 0.4 meters. So with this, we can find what the angular velocity is of this section BD. And it's going to be 5.3 radians per second. 5.3 radians per second. We simply take one of the velocities, we divide it by the distance from that velocity where it's acting to the instantaneous center. Now, if we look at link AB, well, we already know what the velocity of point B is. We can calculate that simply by plugging in our angular velocity and its distance from the instantaneous center to get 2.12 meters per second. And then we already have a distance to the instantaneous center for this guy, which is going to be right here, and a velocity. So we can calculate the angular velocity, which is also 5.3 radians per second. And this makes a lot of sense because it's symmetric. They were at the same angle, 45 degrees here, 45 degrees and 90 between them. They're the same length. It makes sense that they would have the same angular velocity just in opposite directions. Okay, so that's it for this time. Thank you for listening. That wasn't too terrible. And next time we'll jump into another example using our instantaneous center of zero velocity. Have a great day. Bye-bye.